Welcome to our discussion of the equilibrium constant, KEQ. In this video that's part of your equilibrium unit, we're going to define KEQ, write expressions for reactions in equilibrium, perform calculations using equilibrium expressions, and then interpret those calculations. So KEQ is the general expression for the equilibrium constant. Sometimes you may see Kc, which is our equilibrium constant in terms of concentration, and sometimes you may see Kp, which is our equilibrium constant in terms of pressure. But for the most part, for our purposes, we're just going to use the general expression of KEQ. What KEQ tells us is the relative amounts of products and reactants in a system at equilibrium. And that's key. In order for us to use KEQ, our reaction has to be in equilibrium. And since KEQ is essentially a ratio of products to reactants, we write the equilibrium constant as such. KEQ equals the concentration of products over the concentration of reactants at equilibrium. So some things to know about KEQ. First of all, KEQ is always the same for a particular reaction, regardless of the initial concentration of either products or reactants. Secondly, since the concentrations of solids and liquids don't change during a reaction, if a reaction involves solids or liquids, their values are going to equal 1. So essentially, you can leave them out of the KEQ equation. And finally, any coefficients you have in your chemical formula are going to become exponents when you write your KEQ expression. So let's put this all together and practice writing some equilibrium expressions. So let's use that equation from the beginning of the video. Iodine gas plus hydrogen gas gives us hydrogen iodide. And as we recall, our KEQ equals our concentration of our products over our concentration of our reactants. So let's start filling this in. The first thing we should check, however, is the states of all of our reactants and products. Because remember, if they're solids or liquids, we're leaving them out of our expression. But in this case, all of our reactants and products are in the gaseous state, so we're going to include all of them into our equilibrium expression. So for our products, we're going to have the concentration of HI, but also remember that all of our coefficients become exponents, so that 2 is going to become squared. So our products are going to be the concentration of HI squared. For our reactants on the denominator, we actually have 2 of them, so we're going to multiply them together. So on the bottom of our expression, we're going to have the concentration of I2 times the concentration of H2. You don't have to do anything fancy with your subscripts, just bring them along. So the KEQ, or the equilibrium expression for this reaction, is the concentration of HI squared over the concentration of I2 times the concentration of H2. And that's it. That's all there is to it for writing your equilibrium expression. All right, let's try a couple more examples together. So for number 1, remember the first thing to do is check out the states. So I've got gas, gas, gas. So all of my products and reactants are going to be included in my equilibrium expression. So my KEQ equals products over reactants. So my products, H2O concentration, and I have that 2 coefficient, so that becomes squared, over my reactants. And I have H2, but that has a coefficient of 2, so it's actually H, the concentration of H2 squared, times my concentration of O2. And that's it for number 1. For number 2, again, we check out our states, and I have a solid here, a gas, another solid, and a gas. So really the only 2 things I'm going to include in my equilibrium expression are this carbon monoxide and this carbon dioxide. So when I write this for number 2, it's going to be KEQ equals products over reactants. So CO2 squared, because of that 2 coefficient, over my reactants. My concentration of carbon monoxide, also squared. Because remember, we leave out any solids and liquids. So pause the video and give number 3 a try, and then hit play for the answer to see if you were correct. So this one was a little tricky because the only gas we had was this potassium at the very end. So all of our liquids were left out of the equation, so our KEQ is equal to the concentration of potassium. Once we have our KEQ expressions written, we can use those ratios to calculate either our KEQ for a given reaction or the concentration of our reactants and products using our KEQ value. So let's take a look at an example. For the following reaction, it is found that the concentrations of the reactants and products are A at 1.2 molar, B at 0.5 molar, C at 2.3 molar, and D at 3.4 molar. Calculate the KEQ for this reaction. So first we need to set up our expression of products over reactants. So we'll have our concentration of C cubed times D over our concentration of A squared times B. From here, all we need to do is plug and chug our concentrations from the equation into our equilibrium expression. So for C, our concentration is 2.3, so it's going to be 2.3 cubed, and for D it's 3.4 over our A concentration is 1.2 squared, and for B it's 0.5. So when we calculate this out, we get a KEQ value of 57.5. And do note that our KEQ values, as they are ratios, they have no units. Our concentration values will have a unit of molarity or moles over liters, but our KEQ values will not. So what does a KEQ of 57.5 actually mean? Why are we calculating KEQ in the first place? Well, from this ratio of products to reactants, we can actually determine whether we have more products or reactants in a reaction at equilibrium, whether our products are favored or our reactants are favored. If our KEQ is greater than 1, then our products are favored, or we have more products at equilibrium and our reaction lies to the right. This type of reaction is considered favorable. If our KEQ value is less than 1, then our reactants are favored. We have more reactants at equilibrium and our reaction lies to the left. This type of reaction is considered unfavorable. So for this reaction, since our KEQ is definitely greater than 1, we know that we have more products at equilibrium, and we would consider this reaction a favorable reaction. So let's take a look at another example. At equilibrium, the concentration of A equals 4.5 molar, and the concentration of C is 0.8 molar. What is the equilibrium concentration of B if KEQ for this reaction is 0.95? So in this case, they've actually given us the KEQ value, but asked us to find the concentration of one of our products. The procedure is the same as in the previous example. We're just solving for a different variable. So let's see how this works. So the first thing to do, same as always, is to check our states. And for this one, they actually didn't give us any states. So we're going to assume that all the states are gaseous. And the next step is to go ahead and fill out your equilibrium expression of your products over reactants, and then plug and chug and fill in your concentration values, and in this case, our KEQ value as well. Now all we need to do is solve for B, and we find that the concentration of B is equal to 10.5 molar. Don't forget, since we're solving for concentration, that there are indeed units, and those units are molar or molarity or moles over liters. So for our last example, go ahead and pause the video, give this a try on your own, and then when you're ready, hit play to see if your answers match mine. So the first thing I hope you noticed is that they gave us our moles of each of our reactants and products and told us it was in a 2-liter container. So the first thing you actually should have done was convert all of your concentrations into molarity. Next, you should have written your KEQ expression and then plugged in all of your calculated molarity values into that expression. Then once you calculated, remembering to leave D out because D was a solid, you should have gotten a KEQ value of 1.3. And because this KEQ value is greater than 1, that means the products are favored, so there's more products during equilibrium for this reaction. And that does it for this lecture on KEQ. Bring any questions you have with you to class.